You do it every single day. We all do. We type a web address, send an email, connect to something online without a second thought. But behind that simple click is this lightning-fast, totally invisible journey that's zipping across the globe. Today, we're going to pull back that curtain and actually follow a web address on its trip, all the way from your browser to its final home.
It feels instant, doesn't it? You hit enter, boom, the page just appears. But here's the thing. Your computer has absolutely no idea what example.com even means. It only understands numbers, these long strings called IP addresses. So how in the world does it translate a name that we can read into a numerical address it can use? That question right there is at the heart of how the entire internet works.
And this is just the perfect analogy. The domain name system, or DNS, is this massive global phone book. Its one critical job is to look up the human-friendly name you type in and find the matching computer-friendly IP address. Seriously, without DNS, we'd all have to memorize strings of numbers just to check our email. No thanks.
So to really get how this phone book works, we're going to follow a single request, a single DNS query on its epic journey. And it really is a journey, with several essential stops along the way, where each stop plays a very specific role in finding the right address.
Okay, here's our roadmap. Our query is going to make 4 main stops. It starts with a recursive resolver. Then it travels up the chain to a root server, gets pointed to a TLD server, and finally, it lands at its destination, the authoritative server. It's a surprisingly elegant little hierarchy.
All right, let's actually climb that ladder and meet each of these servers. You can think of them as the different librarians and specialists in this giant global internet library. Each one has a very specific job to do. The journey kicks off right here, at the recursive resolver. This is usually a server run by your internet service provider, like Comcast or Verizon. It's the hardworking middleman. When your computer asks, hey, where's example.com, the resolver basically says, I don't know, but I'll find out for you, and it starts the whole search on your behalf. So the resolver's first question goes to one of the 13 types of root name servers scattered all over the world. The root server is kind of like the main index at the front of the library. It doesn't know the specific IP for example.com, but it sees the .com part and says, aha, I know who's in charge of all the .com domains, go talk to them. That next stop is the top-level domain, or TLD, name server. This is the specialist for a specific extension, like .com. It manages every single domain that ends in .com. Now, it still doesn't have the final IP address, but it makes the last crucial handoff. It tells our resolver, I know exactly who has the official files for that domain. Here's their address. And here we are, the final destination, the authoritative name server. This is the ultimate source of truth for that domain. It holds the official file with all the records. It looks up example.com and gives our resolver the prize it's been searching for, the actual IP address. The resolver zips that IP back to your browser, and in just a fraction of a second, the whole journey is over. But wait, that authoritative server isn't just holding a single IP address. It actually holds a bunch of different kinds of instructions called DNS records, and each type has a different job. So let's take a look at the most common ones. This table breaks down what DNS is really doing. The A record is the classic one. It maps a name to a standard IPv4 address. The AAA record, or Quad A, does the same thing, but for the newer, much longer IPv6 addresses. CNAME Records, they're for creating nicknames. And MX records are super important. They tell the internet where to send your email. CNAMEs are incredibly useful. You know how example.com and www.example.com almost always go to the same website? Well, instead of making 2 separate A records with the same IP, you can just make www a CNAME, a nickname, for the main domain. That way, if your IP address ever changes, you only have to update it in one spot. Super convenient. And MX records have this really clever built-in feature for reliability. You can actually list multiple mail servers, and each one gets a priority number. An email system will always try to deliver to the server with the lowest number first. If that server happens to be down, it just automatically moves on to the next one in line, your backup. It's a simple but really effective failover system. Okay, so that 4-step journey sounds a little complicated and maybe a bit slow. If every single click on the internet had to do that whole lookup, everything would grind to a halt. Luckily, the system has a brilliant shortcut built in. So what's this number?
According to a study from MIT and KIST, this is how often DNS lookups get a cache hit. What that means is a whopping 80 to 86% of the time, that whole four-step journey we just walked through doesn't even have to happen. How is that possible?
The answer is caching. It's like a short-term memory. Every server in the chain, your own computer, the recursive resolver, they all temporarily store the answers to recent lookups. So the next time you ask for example.com, the resolver just checks its cache, sees the answers right there, and sends it back to you instantly without ever bothering the root servers. It's a huge performance booster.
As amazing as this system is, it is not perfect. I mean, it's a complex global network that was built decades ago, and things can and definitely do go wrong.
That same study from MIT and KAIST uncovered a pretty surprising reality. In their research, only about 64% of lookups were actually answered successfully. A huge 23% got no answer at all, and another 13% got an error, usually because of a simple misconfiguration or network glitch. What this means is that a huge chunk of DNS traffic is essentially just noise. It's the sound of failed or repeated requests echoing across the internet.
Okay, this brings us to one last really critical idea. What happens when you need to change a DNS record? Like, let's say you move your website to a new server with a new IP address. How does that update get out to all those different caches all over the world?
The whole thing is controlled by a setting on every single DNS record called the TTL, which stands for time to live. The TTL is basically an expiration date. It's a number measured in seconds that tells any caching server, hey, you can hang on to this answer for this long, but after that, you have to throw it out and come ask me for a fresh copy. And this right here is why DNS changes can feel so frustratingly slow sometimes. When you update a record, you literally have to wait for every single cache across the internet that has the old record to reach its expiration date. This slow, gradual, worldwide update process is called DNS propagation. How long this propagation takes depends on a few things. That TTL you set is the biggest one, by far. But some ISPs might even ignore your TTL and cache things for longer. And of course, it just takes time for a change to physically ripple through the entire global network. This can take a few minutes, or in some rare cases, up to 48 hours to finish completely. Choosing a TTL is this fascinating balancing act. If you set a low TTL, say 5 minutes, any changes you make will spread really quickly, which is great. But it also means servers have to keep asking for your records more often, which creates more traffic. A high TTL, like 24 hours, is way more efficient, but it means you'll have to wait a whole day for any of your changes to be seen everywhere. So, from a simple question to a global web of servers and timers, that's the invisible journey the internet takes every single time you click. It's a system so fundamental, our digital world just couldn't exist without it. It really makes you wonder, doesn't it? What other complex, invisible systems are out there, quietly powering our world every single day?